The technical perfection of this launch was equally as staggering. Artemis I achieved orbital insertion with an accuracy of 99.974%. That's a near perfect velocity bullseye, and a level of precision never flown before on a first flight.
The groundbreaking performances of this mission were highlighted further when the ICPS, or second stage, powered Orion through the perigee raise maneuver, followed by the translunar injection, or TLI burn. They put Artemis I spacecraft on a near-perfect trajectory to the moon.
Flight control, ICPS is in attitude control and maneuvering to solar null.
Copy, good news.
The views of our blue marble in the blackness of space, now capturing the imagination of a new generation, the Artemis generation.
The untapped scientific and resource potential of the moon is incredible. The lunar environment will help us better understand the origins of our solar system, to prove the in situ resource utilization and technology demonstrations required to reach even further into our solar system. But none of that is possible without first successfully reaching the moon with a human-rated spacecraft.
After TLI, teams used Orion to reach a never-before-attempted, highly stable, but also fuel-efficient orbit around the moon, the Distant Retrograde Orbit, or DRO.
So we're all set for OpNav coming up here in about 20 minutes.
Correct.
Okay, thanks.
Flying by on the entry to the DRO put Orion within a mere 80 nautical miles of the lunar surface. That was close. And this path used the moon's gravity to slingshot Orion out to a new record for a human-rated spacecraft's distance from our home planet of Earth, nearly 270,000 miles away.
And it was in those harsh environments that Artemis I truly shined, increasing our understanding of how to confidently operate in deep space. On flight day 13, we canceled a planned orbital maintenance burn because it was simply unnecessary. On flight day 20, we ignited the main engine once again and began the long journey back to Earth.
From this view, Orion is 1,277 miles above the lunar surface following its return-powered flyby burn, which sent it around the backside of the moon. Orion now has its sights set on home.
Artemis I set out to fulfill a number of requirements, but the highest priority for this mission was to demonstrate the performance of Orion's heat shield at lunar return velocities. So during re-entry, the largest heat shield of its kind ever made by humans had to prove that it could protect crews from temperatures that exceed 5,000 degrees Fahrenheit. That's nearly half the temperature of the surface of the sun.
Orion hurtled towards the Earth at 24,500 miles per hour, Mach 32, and initiated the first ever skip re-entry. This is the first time that humankind has skipped a spacecraft off the Earth's atmosphere.
For those of us who have flown shuttle, Soyuz or Dragon, coming back to the International Space Station, we wear these Mach 25 patches. This is the return velocity from low Earth orbit. But Mach 32, that lunar return velocity, that's a whole order of magnitude more energy to dissipate. So there we were. Orion had just traveled nearly 1.4 million miles, and it's these last few miles that'll make or break the mission.
We are now in the entry phase.
The team stood silent. Mission control room was deathly quiet as Orion entered the blackout period. And it was tense. We had no telemetry, we had no comms, we had no visual. All we could do was simply wait.
Standing by for a reacquisition of signal.